Hello everyone. In this video, we will be learning about sampling distribution of sample mean. Okay. So the objective of sample is to estimate the population parameter. So while planning for a collection of data, one has to take a decision whether one would like to study the entire population or only a sample drawn from the population. So to understand sampling, first we need to know about the population. As from entire population, we drag the sample. So what means the population? The collection of all the units of specified type of a particular point or period of time is called as a population. So entire unit is called as a population, and the total number of units in this population are generally denoted by capital N. So this is also called as population size. Population size. Okay. And a population is said to be finite or infinite depending upon whether the size is finite or infinite. So population would be finite or infinite based on the size of the population. Okay. So now coming to the sample. So one or more units selected from a population according to some specific method is called a sample. Okay. So we will drag some units points from the entire data, that is called as a sample. Okay. There are two types of samplings. So basically we are going to discuss about here simple random sampling. There are two types of simple random sampling. One is simple random sampling with replacement. Another is simple random sampling without replacement. So these are the two types. Okay. So if we coming to the simple random sampling with replacement. So if we draw an item from the population, we have the choice of replacing or not the item into population, right? But a sampling where each item of a population may be chosen more than once is called as a simple random sampling with replacement, while sampling where each item cannot be chosen more than once is called as simple random sampling without replacement. So for example of simple random sampling with replacement, let us consider A, B, C be 3 units. These are the 3 units in the population. And we want to select a sample of 2 units from this population. Which is of size 3. Okay. So here notation wise capital N is equal to 3, and sample size we denote by small n. Here it is equal to 2. Then total number of possibilities are n to the power n, that is capital N to the power small n. Which means here capital N is 3, small n is 2. So total 9 possibilities are. What are those possibilities? AA, AB, BA, AC, CA, BB, BC, CB, CC. So here ABC is the population size, that is elements of the population. So AA, BB, CC, then AB and BA, AC and CA, BC and CB. Total 9 possibilities are there when the simple random sampling is with replacement. And if we are discussing about the simple random sampling without replacement, so here again same data we will continue for this. N is equal to 3, capital N is equal to 3, small n is equal to 2, and total number of possibilities here are capital N, C, N. This is nothing but the combination. C stands for the combination. So here N is equal to 3, so which is 3C2, and we know the formula for the combinations. 3C2 is equal to 3 factorial upon 3 minus 2 factorial multiplied by 2 factorial. So which is equal to 3 factorial upon 1 factorial into 2 factorial. 1 factorial is always 1. So 3 factorial is 3 into 2 into 1 divided by 2 into 1. So here it is 3. So out of A, B, C, the possibilities without replacement are AB, AC, BC only, right? So if I am considering A with BC, then B with C. So AB, AC here and BC. So these are the 3 possibilities if sampling is without replacement. Okay. Now the next we need to understand is what are the notations to be denoted for the to denote this mean. What are the notations to be denoted for mean of the population and mean of the sample? Okay. So here the notations, the words we use are population parameter and sample statistic. Population parameter and sample statistic. So here let us denote the notations. Population size we denote by capital N, whereas sample size we denote by small n. Okay. Population mean is mu and sample mean we denote it as x bar. Okay. Population standard deviation is denoted by sigma. Sample standard deviation we denote by small s, and population proportion is small p and sample proportion it is p bar, small p bar. So these are the data related to population, we use it as a parameter, and related to sample we call it as a statistic. So statistic means it is something we are using the notations related to sample, and wherever we are using the word parameter means it is related to the sample. Okay. Now let us discuss sampling distribution of sample mean. Sampling distribution of sample mean. Here case 1, simple random sampling without replacement. So it is a probability distribution. Let us consider a population, and from this population we can drag a sample 1 and its mean we denote it by x1 bar. Similarly, one more sample we call it as sample 2 and find the mean of this sample 2. So every sample of same size we are taking from the population. So So here in the sample 1, if there are 10 units, so sample mean of 10 units is we are denoting here x bar. Similarly in sample 2 also 10 units we are taking with the technique of simple random sampling, which is a probabilistic sampling. That is where choosing the probability of choosing every unit is equally likely. Okay. Then sample 3 of let us say 10 units size, and denote mean of this sample 3 by x3 bar. In the same way, if we are taking sample n from the same population, and let us denote the mean by xn bar. Okay. So now we have the collection of now x1 bar, x2 bar, x3 bar, xn bar, and we know this is nothing but the notation for the sample mean. So we have the collection of x1, x2, x3 bar, xn bar, and this collection or this distribution is known as sampling distribution of sample mean. Okay. So that is the probability distribution of all these means which are sample means is called sampling distribution of sample mean. Okay. This is called sampling distribution of sample mean, and this distribution we denote by mu x bar. X bar is in the suffix, and this is the mean, that is mean of all these sample distributions, that we denote by mu x bar, and standard deviation of all these sample means is called standard error. Sample standard deviation is called, this is denoted by SE or sigma x bar. So sigma x bar is nothing but the standard error, which is nothing but the standard deviation of all the sample means which we have obtained after collecting the samples. Okay. Now this is brief idea about the sampling distribution of sample mean. Now let us move ahead to discuss the notations and conditions of the sampling distribution of sample mean. So here sampling distribution of sample mean. Okay, if we consider as we know, population is of two types. One is finite population. This is the condition of without replacement. And second one is infinite population. With replacement. Okay. So in finite population with replacement, we know if n is capital N is the population size, small n is the sample size, the formula is n to the power n, and in without replacement it is NCN, just to remember. Okay. So now there are, if population size is finite, then we will check the condition. If n greater than 5% of n. Okay. We will check the condition whether sample size is greater than 5% of n. In that case, we use the formula of standard error as sigma upon root n multiplied by n minus n upon n minus 1. If this condition is not true, then if n less than 5% of capital N, then the formula would be sigma x bar is equal to sigma upon root n. So here this is the formula. There are two conditions which we will apply while solving the examples. Okay. Here under root n minus n upon n minus 1 is called finite population correction factor, FPC. So this is about the finite population. If the population is infinite, then the formula for standard error is sigma x bar is equal to sigma upon root n. So this we have to remember. Okay. So finite population correction factor is to be multiplied in case of finite population when it satisfies the condition n greater than 5% of n. So this we require to understand the sampling distribution of sample mean with replacement and without replacement.